When solving log equations like you see here, the one thing that I like to tell people is that you want to get the log of x that you see on the left by itself. You want to make sure that if you have any add or subtract or multiply or divide on the left side with the log, you want to get rid of that first. Once we have the log of x here, the log base 2 of x on the left by itself, we want to convert that to Bexa. We want to convert that to exponential form, right? So right now, this log on the left, I like to call this log backs, B, A, and X. And what we're going to do is we're going to rearrange it into exponential form that we see on the right. So we take those three parts and just rearrange. So the B is a 2. And then if I look right here where the X is, the X right here is a 5. So that's going to be the exponent 2 to the 5th power equals X. So now all we have to do is multiply 2 times itself 5 times. 2 times 2 is 4, times another 2 is 8, times another 2 is 16, times another 2 is 32. So X equals 32. All right, let's look at another example here. So this one you can see on the left, that's actually being multiplied. That's 3 times log. We want to get the log base 5 of x by itself. To do that, we want to do the opposite of multiplying by 3. We're going to divide by 3 over here, and then divide by 3 over here. And then we're going to go log base 5 of x equals -3. Now we want to convert log backs, right? This is log backs. This is B, A, X. We want to convert that to Bexa. That's exponential form. So here we go. We'll convert. So the B is 5. The X value right here is -3. So 5 to the -3 equals X. Now, if you don't know how or what to do with negative exponents, really what that means is you're just taking that 5 and you're creating a fraction. It's really 1 over 5 to the positive 3rd power. So I know 5 times 5 is 25, times another 5 is 125. So let's take a look at the calculator here. If we were to do this in the calculator, we go new calc, and I'm just going to go 5 to the -3rd power. And you can see there it gives me 1 over 125. You could convert that to a decimal if you wanted to, but we're just going to leave it as a fraction. So this is our answer right here. All right, let's look at one more. So this time we have a couple things going on with the log right here. We want to get this log 5 of x, log base 5 of x by itself. So I have a multiplication, and then if you look right here, we have an add. So we want to start at the bottom of PEMDAS. So we want to start with add and subtract first and do opposites. So to get rid of that +4, we're going to subtract it. Do that on both sides. I have -5 times the log base 5 of x equals 4 minus 4 is 0. All right, we're done with add and subtract. Now let's move up to multiply and divide. Do the opposite of multiplying by -5. We're going to divide. Well, when you divide by -5 on the other side, it's not changing anything. It's still going to be 0. So log base 5 of x equals 0. Now we want to convert log backs, BAX. We want to convert that to Bexa, exponential. So the B is 5. The exponent, x is 0, equals the A value, which is x. Most of you are going to say 5 to the 0 power is 0. Is it? Let's see what the calculator says. I go 5, don't paste, 5 raised to the 0 power is 1. In fact, you can pick any number raised to the 0 power is 1. So the x value is 1. Let's take a look at the original problem that we have up here that I have in green. I'm going to erase some of this stuff here. And let's solve this using the graphing method with the Inspire. Now, when you use the graphing method, you want to split the equation up into 2 parts. I'm going to put this left side here in F1. I'm going to put the right side in F2. We are going to calculate the intersection and look for the x value of the intersection. The x value of the intersection should be 1 since that's our answer. So here we go. We're going to type in this entire, this entire part of the equation at F1. So we grab our calculator here. add a graph. So the left side is -5 log, our base number is 5 of x, and then we want to add 4 plus 4. Type that in and press enter. I don't care what the shape looks like, I just want to calculate the intersection here. On the right side of the equation, it was just a number, it was just 4. That's what we're going to type in. So F2 just gets a number, 4. We want to calculate that intersection right there. So we go analyze graph, intersection, do some shading, and we're looking for the x value of the coordinate, and if you look right there, the x value of the coordinate is 1. So that's how you can solve log equations. F1 on the left, F2 on the right, calculate the intersection, look for the x value.